Hey, welcome back. Let's take a look at polyatomic ions. Poly is a prefix that means many, or at minimum, we're talking about more than one. If you remember from before, binary meant just one of each kind. And atomic meaning atoms. So we will have more than one atom involved in our ions, whether they are plus or minuses. We can also say that our ions will have more than one type of element. If you remember before, binary once again was one element for positive and one element for negative. So the first thing we're going to look at is cations. These are the positive, and in this case it's really just cation, since the only one we're going to worry about is NH4, which has a +1 charge and is called ammonium. So when it comes for polyatomic cations, we really only have one to worry about. Notice we have nitrogen and hydrogen, two capital letters, meaning that there are two elements in one ion. This is one thing. Let's take a look at anions, and they are kind of special. There's multiple different kinds, and so we're going to learn the naming rules so that we really only have to learn a few bases, and then we can apply these rules to name the rest. The first we're going to look at is the prefix per. Per is one more oxygen than any compound with the suffix ate, or ATE. 8 is a suffix used for any compound that has one more oxygen than a compound with the suffix ite, ITE. Ite is a suffix used to describe the base, or you could think of it as kind of the normal number of oxygens for an element. Hypo is a prefix used to describe a compound that has one less oxygen than the base ite, ITE. So here are some polyatomic anions drawn out. You may want to pause this just to get an idea, but here I've organized them by ites and ates. So we have nitrite, chlorite, phosphite, and sulfite. Over here we have all the ates. Nitrate. Notice there's one more oxygen than nitrite. And here we have chlorate. Notice it is one more than chlorite. Phosphate is one more than phosphite. And sulfate is one more than sulfite. Now let's look at the per compared to the ate, and the hypo compared to the ite. So the first one I'm going to do here is the chlorate ion, and we can see that perchlorate would be ClO4. Chlorite, ClO2, it's going to be one less, so it's ClO. And here are the labels: chlorate, perchlorate, chlorite, and hypochlorite. Now let's take a look at the charges that the ions will have. These are all anions, so they're negative. So -3 will only be the phosphorus-containing anions, and that is PO3, phosphite, and PO4, phosphate. There will be 4 -2 charged anions, 2 from the group with sulfur, SO3, sulfite, and SO4, sulfate. Also, carbonate will be here, which does not necessarily have a carbite, and chromate will also be a part of this group. After this 6, pretty much any anion you encounter will have a negative charge. So the negative charge group is basically everything else. Here's an example. Let's take a look at lead 4 sulfate. So here is the name. Let me write the formula. I know I have lead. I know the charge is 4. I know that I have 8. So it will be 1 plus whatever I is. I have memorized that S and P both have 3 oxygens for their ite. So I know that this sulfate containing sulfur will have 3 oxygens for its ite, plus an extra oxygen because it is 8. So I'm looking at an SO4 for sulfate. I remember from before, it was one of the few that were -2. Here are my charges. I see that 4 is my common factor. What do I need the subscripts to be to make 4? 1 and 2. So as I write it out here, I'm going to denote. What I'm saying is 1 sulfur and 42 oxygens, which is not what I want to say. What I'm trying to say is that lead needs 2 sulfates to cancel out the charge, so I'll put a parenthesis around it to denote it is SO4 as a whole twice. So I'm saying SO4 as a whole equals 2, making this the correct answer. See you next time. Bye-bye.